All right, I'm going to go through a few problems, a few examples on quadratic problem solving. So first one, the length of a rectangle is 4 centimeters longer than its width, and the rectangle has an area of 26 centimeters squared. Find its width. So whenever there's problems about geometric shapes, I think it's a good idea just to start by drawing a picture. And so I'll say this is our width, and this is our length. And then I want to get down some equations based on what they told me up here. So we know that the length of our rectangle is 4 centimeters longer than the width. And so we can say that length, in order to get our length, we'd have to add 4 to our width. So L equals W plus 4. And then we're also told that the rectangle has an area of 26. So we know that 26 would be equal to the length times the width. And so I can actually probably go over here and adjust my picture a little bit at this point now to say that instead of length, or L, I can replace that with W plus 4. Alright, so now since L is equal to this stuff, W plus 4, and we're trying to solve for W, been asked to find the width, I'm going to replace L in this area equation over here with what L is equal to, W plus 4. That gives me a new equation, 26 is equal to W plus 4 times W. With some algebra, I have 26 is equal to W squared plus 4W. And since I'm solving for W here, and it's clear at this point that it's a quadratic, I want to get everything to one side. So I'll do 0 equals W squared plus 4W minus 26. So the first thing I'm going to think about here is, can I factor this quickly? And if we're looking for numbers that multiply to negative 26 and add to positive 4, it just doesn't seem like there are easy factors that come to mind. So I'm going to complete the square instead. And I'll go do that over here on the left. So I've got 0 equals W squared plus 4W minus 26. I'm going to rewrite that as W plus 2 squared. That would get me the W squared and the 4W if I were to FOIL that out, but it would also get me an extra positive 4, and so I'm going to subtract 4 to account for that, and I still have the minus 26. So all parts are accounted for. I simplify that as W plus 2 squared, squared minus 30 equals 0. And the rest from here is pretty routine. I'll add 30 to both sides, take the square root, and that leaves me with W plus 2. Remember, that gives me a positive or negative value for the square root. And then I'll subtract 2 from both sides. So I have two potential options for W. I have negative 2 plus or minus the square root of 30. And there's really just one option that makes sense, and it's going to be whichever outcome here is positive between negative 2 plus the square root of 30 and negative 2 minus the square root of 30. And this one is positive. Why don't we take a minute to see what that actually equals. So I get about 3.48 for that as W. And that would mean my length would be about 7.48. And these answers are easily checkable. We just need to confirm that our length times our width is equal to 26, or about equal to 26, since we used approximate answers. So let's take a look. 3.48, 0.48 times 7.48 equals 26.03, so we're set. Alright, here's a second example. The gym at Holy Angels is divided into two sections for the baseball team, the shaded space, and the track team, the unshaded space, to share. as shown in the diagram. The coaches are demanding equal space. What value of x will satisfy the coach's demands? So let's think of a few different ways that we could figure this out, and then once we have a few different models, we can pick whichever one seems easiest to solve. So one way we could approach this would be to say that the unshaded area needs to equal the shaded area, and try to figure out expressions for each one. So let's see. The shaded area is going to be this length times this length. So since across the top here we have a length of 26, but we're subtracting x from both sides of that, that length that I just outlined would be 26 minus x twice, so minus 2x. And similarly, this vertical length right here, since 21 is this entire side and we're taking off x on both sides, that length would be 21 minus 2x. So the shaded area would be 26 minus 2x times 21 minus 2x. The unshaded area, well, that would be the total rectangle minus the shaded area. So that's going to be 26 times 21 minus the shaded area, which we just figured out was 26 minus 2x times 21 minus 2x. I'll try to squeeze that in. Alright, this is certainly doable. We can FOIL this over here. We can FOIL this as well. It'd be the same task in each case, and then figure out what this is, move everything to one side, and do the quadratic formula. But I think we might be able to find an easier model than this. So we could say that, and I'll do this in a different color, that if we want these unshaded and shaded areas to be equal, then they each just need to be half of the total area. And since we can actually figure out what the total area is just by doing 21 times 26, we could say that our unshaded area, or our shaded area, let's do shaded, our shaded area just needs to equal half of 21 times 26. Again, our shaded area is the same expression, so 26 minus 2x times 21 minus 2x just needs to equal half of 21 times 26, which would be the same as 13 times 26, or times 21, that is. 13 coming from 1/2 times 26. And this one here in bright green looks a lot easier to solve than the red one. So let's take a look at that. Okay, so for this side of the equation, for the left over here, I use what we've always called the box method at Washburn. You might use FOIL instead, that's fine. But I'm going to do 26 minus 2x times 21 minus 2x and figure out what that equals. You probably hear Bryn crying in the background. So 21 times 26 is 546, minus 42x, minus 52x, and plus 4x squared. Alright, combining everything on that side gives me 4x squared, and I like to put it in order with x squared first, minus 94x, plus 546 is equal to 13 times 21 is 273. And then now I'm going to subtract 273 from both sides because I have a quadratic that I want to solve, and I know that that always involves setting everything equal to 0, which results in 4x squared minus 94x plus 273 equals 0. From here I'm going to use the quadratic formula just for variety's sake, so I'll say 4 is A, negative 94 is B, and 273 is C. Alright, I'll spare you the details, but after putting that through the quadratic formula with those values for a, b, and c, I got two possible values for x, about 3.39 and about 20.1. So the question is, which one of those is correct? And if we just consult our picture here, if x were 20.1 yards, that would have to be this way and this way, which wouldn't fit on a 21 yard length, right? 20.1 yards in both directions would be 40.2, and that would extend past our available space. So our answer is x equals 3.39, and as always, this would be an easy one to check. So I'm going to leave that to you. Check to see that when x is 3.39, this shaded space is the same as the unshaded space.